This video will go through every problem of the chapter for review before your test tomorrow. The first question says, which of the following shortcuts can be used to prove that two triangles are congruent? So we can use side, angle, side, angle, angle, side, angle, side, angle, side, 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 and HL. We do not use angle, 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 and we do not use angle, side, side. We also don't use side, side, angle. These two are just the same thing but backwards. The second question says, what does CPCTC stand for? So it stands for corresponding parts of congruent triangles are congruent. Then we start going into proofs. So for this proof, remember you always write your given first. Each given will go in its own box. So we'll write JK is congruent to LM. The reason is given. Anytime you add a statement, you must go mark the figure. So JK and LM are sides. They'll both get one tick mark. Then I write down my second given. So JM is congruent to LK. Again, it's given. This time, since I'm marking sides, they'll get 2 congruency marks. Once I've marked all the givens, I'm going to look for vertical angles or a line that the two triangles share. And if you notice, these two triangles share line MK, so I would mark that. I would write down MK is congruent to MK, and we call that reflexive. Remember, you can always write down what they're asking you to prove in this bottom statement box. And so triangle JKM is congruent to triangle LMK. If you look at your picture, we've marked 3 sides, so they are congruent by side, side, side. For our second proof, we're going to write down our givens, write the word given, and then we're going to start marking our diagram. The first given says RX is congruent to SX, so I can mark both of those sides with 1 tick mark. Next it says X is the midpoint of QT. If you look, segment QT is right here. Remember that midpoint means that X is directly in the middle of the segment. And so previously we've talked about how if QT was, let's say, 20, each side would be 10, meaning these are congruent, and so that's how we mark our diagram. So QX will be congruent to XT, and that's what we're going to write down. Another thing that we've mentioned is if we see the word midpoint in a given, it's a vocab word, so we need to use definition of midpoint as a reason. Again, once I've marked both my givens, I need to look for either vertical angles or a reflexive line. Right here, I see vertical angles, so I mark those. I will name the angles. Just remember, you cannot name the angles angle X and angle X because this could be angle X or this. We're not really sure which one's angle X, so we need to be really specific and name it with 3 letters. Remember that the vertex is always the middle letter, so that would be X in this case. So angle RXQ is congruent to angle SXT, and we'll write vertical angle theorem. If I look up at what they're asking me to prove, they're asking me to prove that RQ is congruent to ST. And I know that that means this is a CPCTC proof. So remember, corresponding parts of congruent triangles are congruent. Before I can use that, I always have to state that the triangles are congruent. So you can always name the left triangle or the first triangle, whatever you want, with the letters in any order. So I'm going to just choose R, X, Q. You just have to make sure that the marks match up when you name the second one. So if you focus on the first one, I did RX, which has 1 mark on the side, and XQ, which has 2 marks on the side. So I need to follow the same pattern in the second triangle. So 1 mark, 2 mark. I would name it SXT. If I look at the diagram, ignoring my highlighting, I can see that I have marked 2 sides and the angle between those sides. So that's side, angle, side. In the next proof, we're going to start the same way by writing down our givens. And then we want to mark our givens. So angle S is congruent to angle Q. And then the second given says RP bisects angle SRQ. If you're struggling with these, I highly recommend highlighting. So angle SRQ, you can see how the vertex is at R. So I'm talking about this entire angle right here, right now. It says that RP bisects it. So if I also highlight that, you can now see how 2 angles have been formed by what I've highlighted. So the angles we're referring to right now are these 2. Bisect means cuts in half. So I have these 2 angles being created that are the exact same measurement. And so I'm going to say angle SRP is congruent to angle QRP. If we see a vocab word in the given like bisect, remember that we'll use definition of bisect as a reason. Once I've marked my givens, I'm going to look for either vertical angles or a line that the triangles share. And they share PR, so I would mark PR. The statement I would write is PR is congruent to PR, and we call that reflexive. If you look at what you're trying to prove that SR is congruent to QR. Since I'm saying a side is congruent to a side, I know that this last line would be CPCTC. Corresponding parts of congruent triangles are congruent. Before you can use CPCTC, you always have to prove that the triangles are congruent. So if I name the left triangle SRP, I would name the right triangle QRP. When I look at the diagram, I can see that I've marked 2 angles and a side, and the side is not between the angles. So the side's not between them. So that would make this angle, angle, side. And then now this proof is complete. For this proof, I've filled in all 3 givens, and then I'm going to start marking my diagram. So the first thing I see is HV is perpendicular to GT. Remember, perpendicular means that there are right angles. So HV and GT, so I can see that the right angles would be here and here. Something we've had to memorize is that when we have perpendicular, we have to write 2 statements about perpendicular. The first statement is always angle GAH and angle VAT are right angles. I highlighted the word perpendicular. Perpendicular is a vocab word, which means we're going to use the definition of perpendicular as a reason. So that's statement number 1 that goes with perpendicular. The second statement is angle GAH is congruent to angle VAT. And that reason is all right angles are congruent. So now I've used and marked my first given. The second given said GH is congruent to TV. So we're going to mark that. GH, TV, both get 1 mark. And lastly, we have A is the midpoint of HV. So here's HV. A is right in the middle. Again, thinking back to our first proof, if this entire segment was 20, each side would be 10, which means these are the same length. So I would mark HA congruent to VA, and that's what we're going to write down. Since the word midpoint is a vocab word in the given, we're going to use definition of that word as a reason. So definition of midpoint. And then looking at what they're asking me to prove, they wanted me to prove triangle AGH is congruent to triangle ATV. And if you look at the diagram, I have a right angle, the hypotenuse, and a leg. So this would be HL. On the next proof, I've filled in each given, and then we're going to start marking the diagram. So the first given says AF is parallel to BD. You mark parallel lines with arrows going the same direction. Remember, parallel lines mean to look for angle pairs. So if I highlight these, I'm going to highlight AF, going to highlight BD, and I'm going to highlight another segment that touches both of them. If I draw you a small diagram off to the side here, here's kind of what we have. So this is more like what we were looking at when we had angle pairs. Hopefully you could notice here and here, I have corresponding angles. If I transfer that to my diagram, that would be these two angles. It's very important that you don't mark those with right angles, even though they kind of look like they might be, because nowhere does it say perpendicular or right angles. So I'm going to write down angle AFD is congruent to angle BDC because those are corresponding angles. And then I'm going to check off that I used the first given. The second given, AD is parallel to BC. This time I want to mark these parallels with arrows going in the same direction, but I need to do double arrows. Again, if I highlight, I'm going to use a different color. I have these two segments. They both touch this segment here. If I drew you a diagram off to the side, this is kind of what we have. Hopefully you would notice that these are also corresponding angles, and that's what would get marked in our diagram. I'm going to name those with 3 letters, so angle ADF is congruent to angle BDC. Again, they're corresponding angles. The last given is D is the midpoint of FC. So I'm looking at this segment at the bottom. D is the middle, which means each half is congruent. So FD is congruent to CD. If I see the word midpoint in the given, I have to use it as a reason, so definition of midpoint. Now, I've marked all of my givens. I have 3 marks on each triangle. I have enough to prove that they're congruent, so triangle AFD is congruent to triangle BDC is what they were trying to get me to prove. Remember, when you look at the triangles, we're going to ignore the arrows and just look at angles and sides. So I have an angle, a side, an angle. That's angle, side, angle. On the next proof, I'm going to fill out my givens, and then I'm going to start marking the figure. Again, from the last proof, remember, AD parallel to BC, we mark those with arrows, and it means we're looking for an angle pair. An easy way to find an angle pair is to highlight. So I have AD, I have BC. You find one other segment that's going to touch both of those. So I'm just going to choose this one. There's actually more than one in the diagram. This is just what I saw first. If you notice, it outlines 2 angles for you. So it outlines this angle and this angle. So angle D is congruent to angle B. And those are alternate interior angles. So I used the given. Next, I see F is the midpoint of BD. So F is the middle of this segment. That makes these two halves congruent. So BF is congruent to DF, and that's definition of midpoint. Once I've used both givens, I look for either vertical angles or a reflexive line, and I see that I have vertical angles. I need to name those with 3 letters, so angle AFD is congruent to angle CFB, and that's vertical angle theorem. If you look at what they're asking you to prove that angle ADF is congruent to angle CBF, which means this last line is going to be corresponding parts of congruent triangles are congruent. Anytime you're using CP-CTC, you have to show that the triangles are congruent first. So I'm going to have triangle ADF is congruent to triangle CBF. If I look at my diagram, again, we don't want to include the arrow when we're talking about which shortcut we used. So if you look, I have 2 angles and 1 side, and the side is between the 2 angles, so that's angle side angle. In our final proof, we start by writing down the givens, writing given as a reason, and then marking our figure. AB is parallel to DC is our first given. So we mark the parallels by arrows going the same direction, and then we're looking for an angle pair. If you highlight the 2 parallel lines, you can see that BD is the segment that they intersect, and then you can see that 2 angles have been outlined, and it's these 2. We need to name those with 3 letters, so angle ABD is congruent to angle CDB, and those are alternate interior angles. I also was given that AB is congruent to DC, so we can also add congruency marks to those. Once you've used both givens, you look for either vertical angles or a line that the 2 triangles share, and they share segment BD. So BD is congruent to BD, and we call that reflexive. We're trying to prove that triangle ABD is congruent to triangle CDB, and we've done that using one of our shortcuts. If you look, I've marked 2 sides and 1 angle. The angle is in between the 2 sides, so that's side, angle, side. In the next section, you're solving each triangle for the missing angle or variable. For this first one, we know that triangles add up to be 180 degrees. So if I take 50 plus 80, I get 130. 180 minus 130 is 50. So this missing angle is 50 degrees. In our second example, I know that triangles add up to be 180 again. So I have 9x minus 3 plus this angle of 90 degrees plus 30 degrees equals 180. If I combine my like terms, I have negative 3 plus 90 plus 30. So I would really have 9x plus 117 equals 180. I would subtract 117 from both sides, and I would get 9x equals 63. And when I divide by 9, x equals 7. On the next examples, recall the triangle exterior angle theorem, which says that these 2 remote angles add up to be the exterior angle. So 105 plus 30 equals this missing angle, so it's 135 degrees. Same thing on this next example. These 2 angles add up to be the exterior angle. So I'm adding these, and they equal the exterior angle. So 60 plus 7x plus 5 equals 20x. If you combine like terms, you have 7x plus 65 equals 20x. If I subtract 7x from both sides, 65 equals 13x. And when I divide by 13, x equals 5. On the next example, to start off, I'm noticing that these two angles are vertical angles. So angle A would be 35 degrees. These two angles are a linear pair, which means they add up to be 180. So 180 minus 37 is 143. So angle C is 143 degrees. Finally, using this triangle, I have an angle that's 35 and an angle that's 109. So if I add those together, I have 144. 180 minus 144 is 36. So angle B is 36 degrees. In the very last example, I noticed that this triangle has 2 of 3 angles filled in. So I'm going to solve first for x. 28 plus 39 is 67 degrees. 180 minus 67 is 113. So x is 113 degrees. Next, I see that x and y are a linear pair, which means they add up to be 180 degrees. So 180 minus 113 is 67. So angle y is 67 degrees. Lastly, I see this triangle, which I now have 2 of 3 angles filled in. So 64 plus 67 is 131 degrees. 180 minus 131 is 49. So angle Z is 49 degrees.